Why do some people bounce back quickly from setbacks, while others spiral into prolonged distress? When faced with job loss, relationship breakdowns, or unexpected tragedy, what separates those who recover from those who remain stuck? For decades, we attributed this difference to willpower, character, or some vague notion of mental toughness. But neuroscience reveals a far more fascinating truth: resilience. The ability to withstand and recover from adversity has a specific neural signature. People with resilient brains aren't just thinking differently. Their brains are literally wired differently. Welcome to the science of resilience, where psychology meets neuroscience to reveal how unbreakable minds are made. Resilience isn't just bouncing back. It's a complex neurobiological process involving multiple brain regions working in harmony. Research from institutions like Harvard and Stanford identifies 3 critical brain areas that determine how we handle stress. First, the prefrontal cortex, your brain's executive control center, acts like a wise supervisor, regulating emotional impulses and making rational decisions under pressure. Second, the amygdala. Your threat detection system sounds the alarm when danger appears, triggering fear and anxiety responses. Third, the hippocampus. Your memory consolidation hub provides context, helping you learn from past experiences and regulate stress hormones. Here's where it gets fascinating. Resilient individuals show stronger functional connectivity between the prefrontal cortex and the amygdala. Brain imaging studies reveal that when resilient people encounter stressful stimuli, their prefrontal cortex activates rapidly, effectively dampening the amygdala's panic response. It's like having a skilled negotiator who can quickly calm an alarm system that's too sensitive. In contrast, less resilient individuals show weaker prefrontal amygdala connections, meaning their emotional alarm systems run wild with minimal executive control. This isn't just theoretical. Researchers can actually measure this connectivity using functional MRI and predict with surprising accuracy who will develop PTSD after trauma and who will recover normally. Those with stronger prefrontal amygdala coupling before trauma are significantly more likely to emerge psychologically intact. The hippocampus adds another layer to this story. This seahorse-shaped structure not only consolidates memories, but also regulates the HPA axis, your body's primary stress response system. When you encounter a threat, your hypothalamus signals your pituitary gland, which triggers your adrenal glands to release cortisol, the stress hormone. This cascade prepares your body for action. Elevated heart rate, increased blood pressure, heightened alertness, crucial for short-term survival, but devastating if chronic. Here's the remarkable part: resilient individuals have larger hippocampal volumes on average, and their hippocampi are better at negative feedback regulation. This means they can shut down the stress response more efficiently. Once the threat passes, their brains essentially say, "Okay, we've dealt with this, time to return to baseline." Less resilient individuals often have smaller hippocampi that struggle to turn off the cortisol tap, leading to chronic elevation that damages the very neurons responsible for stress regulation. It's a vicious cycle. Stress shrinks the hippocampus, which reduces stress regulation capacity, which leads to more chronic stress. But here's the empowering part: resilience isn't purely genetic. Twin studies suggest that only about 30 to 50% of resilience variance comes from heredity. The rest is shaped by environment, experience, and most importantly, trainable skills. One of the most robust findings in resilience research involves emotion regulation, the ability to modulate the intensity, duration, and expression of feelings. The strategy most strongly linked to resilience is cognitive reappraisal, consciously reframing a situation's meaning. Instead of viewing a job loss as catastrophic failure, seeing it as an opportunity for career redirection. Instead of interpreting criticism as personal attack, understanding it as valuable feedback for improvement. Brain imaging shows that cognitive reappraisal literally changes neural activation patterns. When people engage in reappraisal, Their prefrontal cortex lights up while their amygdala quiets down. They're not suppressing emotions that actually increases stress. They're changing the story their brain tells about what's happening, which transforms the emotional response at its source. Compare this to emotion. Suppression trying to hide feelings without addressing their cause. Suppression looks fine on the surface, but creates internal chaos. Elevated heart rate, increased sympathetic nervous system activation, and decreased heart rate variability. Over time, habitual suppression erodes resilience. Reappraisal, by contrast, reduces physiological stress responses while maintaining or even improving social functioning. Social connection provides another critical pillar of brain resilience. Humans are profoundly social creatures. Our brains evolved in tribal contexts where isolation meant death. This evolutionary history explains why loneliness activates the same neural alarm systems as physical pain. Brain scans show that social rejection lights up the anterior cingulate cortex and insula regions that process physical pain. But positive social connections do the opposite. When you feel supported, understood, and valued, your brain releases oxytocin, often called the bonding hormone. Oxytocin does something remarkable. It reduces amygdala reactivity, effectively turning down your brain's threat detection sensitivity. It also activates the parasympathetic nervous system, promoting calm and recovery. Large-scale studies find that strong social support networks are among the most powerful predictors of resilience, sometimes outweighing individual psychological factors. The mechanisms are fascinatingly specific. When you share difficult experiences with empathetic listeners, mirror neurons in both brains synchronize, creating shared neural states. This neural resonance doesn't just feel good, it actively reorganizes stress-related neural pathways, helping integrate traumatic memories in ways that reduce their emotional charge. Physical exercise emerges as one of the most potent resilience-building interventions, and the neuroscience explains why aerobic exercise triggers release of brain-derived neurotrophic factor BDNF, essentially fertilizer for brain cells. BDNF promotes neurogenesis in the hippocampus, actually growing new neurons in the very region responsible for stress regulation and memory. A landmark study found that 6 months of regular exercise increased hippocampal volume by approximately 2% in older adults, accompanied by improvements in memory and emotional stability. Exercise also recalibrates your stress response system. Regular physical activity reduces baseline cortisol levels and improves HPA axis. Responsiveness: you still react to acute stress, but you recover faster. Additionally, exercise activates dopamine reward pathways and increases serotonin availability, creating neurochemical conditions that support positive mood and motivation, even during difficult times. The dose matters. Research suggests that 30 to 45 minutes of moderate to vigorous aerobic activity, 3 to 5 times weekly, produces optimal brain benefits. Interestingly, exercising in natural environments, green exercise shows enhanced effects, possibly because nature exposure independently reduces amygdala activity. During sleep, your brain performs critical maintenance. Slow-wave sleep facilitates memory consolidation, transferring information from the hippocampus to long-term cortical storage. REM sleep processes emotional experiences, essentially providing overnight therapy. Brain imaging reveals that sufficient REM sleep reduces amygdala reactivity the next day, while REM deprivation leaves you emotionally raw and reactive. Mindset: your fundamental beliefs about yourself and the world profoundly influences neural stress responses. Stanford psychologist Carol Dweck's research on growth versus fixed mindsets reveals that simply believing abilities can improve through effort changes. How the brain responds to challenges. People with growth mindsets show different neural activation patterns when facing difficulty, enhanced prefrontal activity, and reduced threat responses. Even more striking, believing stress can be enhancing, rather than purely harmful changes, physiological responses. Participants taught to view stress as preparing them for peak performance, showed healthier cortisol patterns and better task performance than those viewing stress as harmful. Their beliefs literally altered their neuroendocrine responses. Perhaps most remarkable is the phenomenon of post-traumatic growth, psychological improvement following adversity. Not everyone who experiences trauma develops PTSD. Some emerge with deeper relationships, greater appreciation for life, enhanced personal strength, and new possibilities. Brain imaging of individuals experiencing post-traumatic growth shows enhanced prefrontal amygdala connectivity and improved hippocampal function, essentially. The trauma catalyzed neural reorganization that increased resilience. If you found this exploration of resilience neuroscience valuable, please like this video and subscribe to the channel for more science-based insights into optimizing your brain and mental health. Thanks for watching, and remember, your brain's capacity to adapt and grow is far greater than you imagine.